forward to talk to you guys today about RESTful Java. Let me get this screen going. Okay, hopefully you guys can see this. I'm very excited to be here at JCON. And like I said, we're going to talk about RESTful Java. I've got a lot of information I want to send out, so I would like to ask that we keep questions to the end, and that way, hopefully, we'll have more time for Q&A. All right, let's get going. So who am I? I'm Andy McCright. I've been a web services architect and RESTful services team lead at IBM for the past 5 years. I'm an infrequent blogger. I'd like to blog more, but life seems to kind of get in the way. I also wrote a book with some colleagues of mine called Practical Cloud Native Java Development Microprofile. You know, what I'd like to do, if we could, is give some of these away. So if you're interested in getting a digital copy of this book, it just came out a week and a half ago. What I'm going to do is I'm going to give away 3 copies, and I'll tell you how kind of at the end of the presentation. So if you're interested, you know, stick around. Lastly, I'm an assistant youth soccer coach. We call it soccer here in the US. I know you guys call it football, and an amateur musician. So who is this presentation for? Ideally, it's for beginners in the RESTful Java space. If you've done a lot of development in RESTful Java, hopefully you'll still be able to benefit from some of the information in here. Hopefully you'll be able to see things that you can kind of see like, oh, I could have chosen to go down that path instead of this one, and see some of the pros and cons of those decisions. But ideally, if you're new to the RESTful Java space, I think you'll find a lot of this very useful, because it'll help you kind of choose which path you want to go down and why you might want to avoid certain paths. So I have some disclaimers before we begin. First of all, nobody is unbiased. Anybody that watches the news knows that there's always some form of bias. This presentation is particularly unique because I work for IBM. I work on the JAX-RS project. I work on MicroProfile project, and I'm going to be talking about the strengths and weaknesses of something I work on as compared to some of our competitors. And so what I want to do is anytime I get to be a little bit too biased, I want to put on my bias cap. So when you see this cap on, you might want to take what I'm saying with a grain of salt, and it may come across as more of a fanboy talk as opposed to actual technical fact. The other disclaimer is completeness. Like I said, this is intended for beginners. What I'm hoping to provide is a nice springboard so that you can then do more research and figure out, at least get some general idea as to how you might start with a RESTful Java application, and then go do more research and figure out, first of all, if what I'm telling you is still accurate, or if there's been changes in that space. The space is still evolving fairly rapidly, but also so you can find more and learn the more advanced techniques in all of these fields. All right, so what we're going to cover today is we're going to look at 3 major framework and APIs. We're going to look at Jakarta REST, which is also known as JAX-RS, and how it ties in with the MicroProfile REST client. We're going to talk about Spring MVC REST. Those 2 are probably the 2 most popular based on the survey results that I have. I did a survey about a month and a half ago and got some interesting insights, which I'm hoping to be able to show you at the end. But thirdly, we're going to talk about MICRONAUT, which is not very popular as far as I can tell, but it's still a very useful, I think very cool alternative to the more mainstream JAX-RS and Spring options. So then what I want to do is go through each of those and then show you what you can do with them, how you can get a simple hello world up to date, up and running, how you can use other HTTP methods besides just your standard GET methods, talk about error handling, talk about how you can filter requests, and how you can sculpt or shape your response data, and do all of this with the APIs that we mentioned above. If we have time, we'll talk a little bit about client APIs and survey results, If we don't get time, all of these slides are available out on the internet. I posted a link in the chat. I've also got a link to my Twitter account if you have any questions afterwards. All right, so with that in mind, let's talk about JAX-RS. JAX-RS is probably the oldest. It's probably the most mainstream, although it's questionable. Spring MVC REST is also very popular, but it's definitely one of the top two. And it was introduced in 2008, and then in 2017, Oracle, who had owned the JAX-RS and as part of the whole Java EE sector, basically open sourced it all and gave it to the Eclipse Foundation to steward. And so JAX-RS was officially renamed to Jakarta RESTful Web Services, but that's kind of a mouthful. So most people are just going to call it Jakarta REST or JAX-RS. And that's what I'll be calling it in this presentation. So JAX-RS is a specification. It's not, you can't just go out and download and run a JAX-RS framework. It's a specification, a set of APIs that are then implemented by vendors, right? So we'll talk about some of those on the next slide. But the idea is that you get the specification APIs, you get the implementation, and then you build your code, your application to those APIs, and it should run the same whichever implementation is implementing those APIs. So some popular implementations of JAX-RS include Apache CXF, Eclipse Jersey, and REST Easy. And so depending on the implementation of your server, that you may be kind of locked in to one of those. For example, Open Liberty is a server that I work on. It uses CXF. And in future versions of JAX-RS, we're going to look at using REST Easy. Glassfish uses Eclipse Jersey. So you've got different options. The other nice thing about those three is you can just pick it, pull down that implementation and stick it into a web container like Jetty or Tomcat and run a JAX-RS application very lightweight. So you have a lot of options when it comes to the implementation of JAX-RS, and each implementation and each different server environment has its own bells and whistles that might make it a little bit more suitable for your needs than another. Spring MVC REST, on the other hand, is a little bit more locked in. It is an implementation as well as the specification, right? So you code to some Spring APIs, but you run it in a Spring environment. And it makes it real easy to deploy on things like Spring Boot, etc. And the other nice thing about Spring is that it can be deployed in Jakarta EE app server. So you could take a Spring MVC REST app and run that in Open Liberty or Wildfly or Quarkus or even the smaller web containers like Jetty or Tomcat. MICRONAUT is something I think is, I don't know how popular it is over in the EU, but when I did my survey, virtually nobody had heard of it, and then those that have heard of it have never used it. So it definitely seems a little bit less popular. It's a full stack framework developed by the creators of Grails, and it works with Java, Groovy, and Kotlin. It uses some Jakarta and Java EE technologies like CDI, but for the most part, it provides competitive programming models to these other Jakarta technologies. It does offer some JAX-RS functionality. So you can use some JAX-RS APIs and code to those. However, it's not a complete implementation. So you wouldn't want to write your application for JAX-RS, build a full-featured application, and then migrate it to MICRONAUT and expect it to work completely with no behavior issues, because there are some differences in what how MICRONAUT implements their behaviors. MICRONAUT is very quick starting. It's similar to Quarkus in that it integrates very well with Graal VM, and its startup time is super quick, and it runs very, very fast and efficient. And So I do want to take a quick note on deployment. All of these are cloud native. So you can run your, write your application for MICRONAUT, Spring, MVC, REST, or JAX-RS and deploy to the cloud without issue. And there's lots of documentation out for all three on how to do that. So I'm probably not going to cover a lot of that in this session. All applications can be packaged as WARs, as web application archives, or as Über jars. All can be deployed in things like Spring Boot, OpenShift, Docker. So again, since there's very little difference in how you would deploy these things, I'm probably not going to cover a lot of that in this session. If you have questions on it, though, I'll be happy to talk about that when we get to the end. So let's get to what a hello world looks like. This is very much taken from a Spring guide. And what I've done is I've basically rewritten the code from that Spring guide to do the same thing in JAX-RS and MICRONAUT. So it uses a greeting class. It's just a simple POJO that has an ID and a string for the content. And so the idea is that this would be returned back as JSON to the user. Very simple, it's hello world, right? So we have a class over here called hello controller. In JAX-RS terms, we would call this a resource class, and it has an path annotation to tell you where you would access this resource in the HTTP URI. And we've got a produces annotation to indicate what type of media, what our content type is that we're going to return. So when somebody runs a request to our local host and with /greeting, we're going to return a new greeting that increments our ID counter and sends back a message of hello world. That's our default value is world. If a user specified question mark name equals Andy, then it would return back hello Andy. So very simple. This is what it looks like in Spring. So the POJO is the same, but what we have over here is we have a REST controller annotation. We have our get mapping with our path down here on the get method, and it does basically the same thing. It simply returns a greeting object. It returns the POJO, and the framework converts that POJO into JSON, just like JAX-RS. It's very similar. So we get the same results when we run this on our local host environment. MicroNaut is a little bit different. It has a little bit of a quirk here in that you need to specify that it consumes ***. Otherwise, it's expecting the content type of the request, even if there is no content, even if there is no HTTP entity body, to be application JSON. So you need to specify what it consumes and what it produces. This is all done in the controller annotation. It also contains the path up here. And we have a similar to JAX-RS, we have an @get annotation telling us this is the method we want. And this is our query value. It's looking for name, and its default value is world. So all three of these are very similar. We don't have a lot of differences here between our three implementations when it comes to our simple hello world application. So now we're going to look at other HTTP methods. So all of them will have all three APIs will have annotations for post, for put, for delete. Most of them will have them for options and head as well, which are fairly less well used. But one of the things that we will see some differentiation here is on how you would add your own HTTP method. So for example, let's say we want to have an HTTP method called prepend or append that would basically just allow the content body to prepend or append to the existing resource at that location. Well, what we would do in JAX-RS is we would create a prepend annotation, and we'd annotate it with HTTP method, and then pass in the text we want to use for the HTTP method. So in that case, it would be prepend. I've seen other people out on Stack Overflow ask the same question, and you want to use things like copy or use something like that. So you could easily build your own HTTP methods to give you more flexibility in your RESTful application by using this annotation. Now, I guess I should probably put my cap on for this, but Spring doesn't give you that same level of control. Spring has an enumerated type, and these are the HTTP methods that you can use with Spring MVC REST. So it is a pretty wide set, but if you want to go beyond that, let's say we wanted to have that prepend or append annotation and use that as our HTTP method, you just can't do it in Spring. There is a possible way to do it. I haven't investigated it myself, but I put a link here to the Stack Overflow question. It is possible, apparently, to implement your own dispatcher servlet and then customize the request mapping handler adapter for Spring in order to get other methods. Ultimately, it seems like a lot of work. So my advice would be, if you're planning to use sort of non-standard HTTP methods, might want to consider JAX-RS or MICRONAUT. Let's take a look at what MICRONAUT does. I can take my cap off now. So MICRONAUT has the same add, post, get, put, and delete methods just as everybody else. What they do different for custom HTTP methods is they actually have a custom HTTP method annotation, allowing you to specify it right here. So a different way to do it than JAX-RS, but still very powerful and flexible nevertheless. Next up is error handling. So error handling, this is less about how you should handle errors internally in your application and more about how you want to express errors back to your client. So if you're building a service, most RESTful applications are going to return a 400 range message if there's a client error. If they request a resource that isn't there, or if they forget to add a specific header that they need. 500 range is for server errors. That would be like, hey, like the database is down, or we're accepting too many requests, we're too busy. So ideally, when you return an error response, one of these HTTP 400 or 500 codes, you want to have some kind of body in it that tells the client what kind of corrective action they can take. So if you're too busy, maybe you send back a 504 and you say, try again in 30 minutes. Or if somebody is trying to send you JSON, but you don't, or I'm sorry, they try to send you XML, but you don't accept XML, you only accept JSON, you want to send some message back saying, hey, these are the types of data that we accept. We accept JSON or YAML or whatever. So something like that is very useful. And so RESTful servers, pretty much all three of these, will do some level of automatic responses. So they'll respond back with things like, if you send a request for something outside of it where you don't even have any paths. So for example, you have a path for @greeting or /greeting. You may not, if somebody attempts to access /foo and you don't have anything that recognizes /foo, your server framework is going to automatically return a 404. But if you want to give a little bit more information, if you want to customize the error response that the client sees, that's what we're going to talk about next. So one option you can do is just throw an exception that has the details in it and let the framework convert that exception into a useful response. So I apologize, it's a little bit hard to see. You might have to zoom in. But up here at the top, we have our JAX-RS. And basically what that does is it catches a duplicate key exception, because that's an application exception, that's a business exception. And then it throws a web application exception, which is part of the JAX-RS APIs. And then inside of that, it sends a response with status 409, which indicates conflict, HTTP conflict. So that means somebody tried to post something that's already there. And so there's a conflict. And then it has a message body of duplicate key. And then it sends whatever's in that the duplicate key exception as part of the response. Spring is very similar. It has a response status exception. You throw it. Here again, you're limited to an enumerated type of HTTP status. So you don't get to choose your own response codes. You have to choose from one in the HTTP status enumerated type, but you can send a message here. Note that you do have to set an application property in order for the message to be sent. A lot of times, I think Spring is trying to be cautious in not letting you send too much information that might be insecure to your client. So you have to opt in to send messages back in this case. MICRONAUT, you don't throw an exception per se, but what you can do is rather than returning a response or a void in this case, which would lead to a 204, a no content, you can change it to return an HTTP response object. And then if you return, you basically would put your normal response object, say you're returning a widget or a greeting object, you would return that in the HTTP response. But likewise, you could just build an HTTP response that uses HTTP status conflict and returns the body message. What I think is a little bit more useful and more flexible are global handlers. And so what global handlers do is they basically say, if you throw an exception in your resource method, so if we go back, let's go back to this guy. So we see here that like you could throw an invalid key exception or an unknown key exception. What you could do is with our global handler is if the framework receives an exception of that type, it will map it using an exception mapper to the response. So we have a response here. This time it's a bad request. It's saying invalid key. So it's going to return a 400 with this message here, indicating that there was an invalid key. So we take a business exception here and convert it into an HTTP response or a RESTful response for your clients. Spring is very similar. They have a props exception handler. And so you would just extend this response entity exception handler, add a controller advice annotation, and you can specify multiple methods. This is actually kind of nice with Spring. You can have one handler that handles multiple different exception types. So in this case, we've got an invalid key and an invalid value exception. So if you throw either one of those exceptions out of your controller class or your resource class, you'll get to this point here, and then it will return back with the web request here. So it'll show you an HTTP conflict, and it'll return the response body that we have here, indicating either an invalid key or an invalid value. And later on, if some other exception throws, or sorry, some other resource method throws an unknown key exception, well, then we can throw a not found, a 404 error here, indicating that the key doesn't exist. So this is pretty slick. You can have multiple exceptions handled by the same class in Spring. In MICRONAUT, also very similar. It has an exception handler class, and it's very similar to JAX-RS in that it basically responds or maps a exception of your choosing, a business exception, into an HTTP response. So next up is filtering. So there might be times where you, for example, don't want a request to get to your resource method. Maybe there's something malformed that you want to look for before you allow it to get to any method, or perhaps you want to massage the request a little bit before it gets to the method. So in JAX-RS, you would use filters for that. So in this case, we have a container request filter. There's also a container response filter that's on the backside. So that would be like if you wanted to further massage or sculpt the response going back to the client. But the request filter here is what we want to look at. And in this case, what I've done for an example is to show like maybe we only want certain IP addresses to be able to access our resource. So we have a filter here. It's enabled by adding this provider annotation. We inject an HTTP servlet request, and then we check from the servlet request it's the remote address of the client, and then we check whether it's allowed or not. And in this case, in my sample code, it's all going to be just localhost. It will say if it's not an allowed IP address, we're going to abort with, and then we send a response back here, and we have a custom response here saying unauthorized request must be from the local address. So it's a pretty nice way to modify the request, or either modify the request or abort the request before it even gets to your business method. In Spring, things are a little bit more complicated. There's a little bit more code, but you can do the same thing. So you have a handler interceptor. You have this pre-handle method, and you get the HTTP servlet request just like we did in JAX-RS. The trick is that it's got to be kind of manually registered over here in your web MVC configurer. But otherwise, it does very much the same thing. So we get the address, we check to make sure it's allowed. If it's allowed, we return true. This is basically a true false kind of thing. If you say true, that means you can go to the next filter in the chain, or it means that if you're the last one, it means time to invoke the controller method. If it's not true, then if you return false, that means you're going to abort at that point. And so you need to make sure that you've updated the response to show why. So in this case, we're saying we're setting the status to 401 and giving a message of the request needs to be from the local address. MICRONAUT has an HTTP servlet filter, and basically it's very similar to, it's kind of in some ways a combination of both. It returns this HTTP response. And so you would call the response unauthorized if you're going to do that. Otherwise, you would call chain.proceed. So this is similar. If you're familiar with CDI interceptors, it's very similar to that. So this is effectively in a round invoke. So you could do work on the front, on the incoming side up here, call the proceed method. And then if you wanted to do additional work, if you wanted to massage the response, you would do that after you call the chain.proceed method. Now we're going to talk about sculpting the response data. So by default, Spring and MICRONAUT use JAXON to convert returned objects to JSON. JAX-RS uses JSON-B because that's the Jakarta EE technology. So by default, Spring and JAX-RS perform content negotiation based on the accept header. So when a request comes in, it can basically say, hey, I really want the response to be in XML, or I really want it to be in YAML or whatever. And you can actually set multiple ones as well. You could say, I'd really prefer JSON. I'll give it a Q value of 1. But if you don't have JSON, XML is my second best choice, and I like that at 0.75. And if you don't have that, well, if you got a semi-YAML, and that's at 0.25 or something like that. And that content negotiation will take place with the server. It will find the best match and return the response object in that specified content type, that MIME type. So Spring and JAX-RS does that automatically. MICRONAUT does not. And so what that means is MICRONAUT, if you're using MICRONAUT and you're using non-JSON types, you have to do a little bit of this manually. So how do we do that with JAX-RS? It's basically you use the @consumes and @produces annotations that says these are the content types we will consume, as far as will allow you to send our service these content types, and produces is these are the types that we will return back to you. So in this case, I'm just using the same. It's going to be JSON, XML, or YAML for our person controller. But then when you actually return those, all of the responses go through in JAX-RS go through what's called a message body writer. So it's basically going to take the object. So it's going to take in this case, a person object or a widget object or whatever it is you return, and it's going to serialize that to the type that's been selected. So if you're using JSON, well, then it's going to use JSON-B to serialize your person object into the JSON text. If it's going to use JAX-B to serialize it to XML. And so if you wanted to use YAML, by the way, both of those are provided out of the box with all JAX-RS implementations. But if you're going to use YAML, that's not provided out of the box. So what I've shown here is a message body writer and reader that uses Snake YAML to read YAML and write it. And so you basically have these write methods, write to and read from, that grabs the incoming stream as an input stream and reads that into an object. So it uses the YAML classes to load that into an object and returns it. And likewise, when it writes it, it gets an object and writes that out back to the response. With Spring, it's very, very similar. You specify the consumes and produces inside the request mapping annotation. And so you could even be more specific, right? You could say like the class by itself produces JSON, XML, and YAML, but you don't need to consume anything because most requests might be GET requests or delete requests that don't take any data. So you could put that consumes annotation or consumes value of the annotation down here on the actual individual method levels. So then over here, it uses an HTTP message converter, and it uses the same kind of syntax. So as a message body reader and message body writer, it's just all one interface. So you have a can read and can write. So basically, this is where you do your check to make sure if they have an accept header of application/YAML, then we'll use it, and then we'll use the Snake YAML APIs to read or write the data back to the client. As I alluded to before, we got an unhappy guy here because sculpting with MICRONAUT is not, it's not as easy as it would be with the other two. So content negotiation has to be handled in your own code. We showed before where if you wanted to use, if you wanted to, instead of throwing an exception, if you wanted to just create the exception type, you could use an HTTP response return type on your method. This is basically what you'd have to do if you wanted to sculpt it. So let's say you wanted to be able to handle JSON, XML, and YAML. You would have to have some code that basically says, okay, go read the HTTP request, tell us what was the content type header, what was the accept header, and then return a response that you've already pre-serialized for XML or YAML or JSON. So it's a bit of a disadvantage compared to the other two. All right, so we're getting near the end. I may actually be able to have. It looks like I've got a little bit more time. So let me skip ahead real quick. Let's talk about how you could get started. If you're interested in JAX-RS, there's a few links here that have some starter code. This most recent one, the bottom one here, is for EE9. The others are for EE8. And then if you're interested in getting started with Spring MVC REST, you can start with this guide and then use the Spring initializer, or you can go to the MICRONAUT launch site if you want to get started with MICRONAUT. Got a link to all my source material here. And since we've got a little bit more time, I'm just going to talk real quick about client APIs. So all three of these have their own client APIs. All three have a programmatic or low-level client API where you basically kind of work at very similar to HTTP layer. It's basically one layer above URL connections, if that helps. So you're basically creating targets and then invoking those targets and reading responses. So it's fairly low level, but it can be very dynamic and very, very powerful. All of them also have a type safe or declarative client API where you basically write an interface, and that interface represents your remote service. You decorate it with annotations similar to how you would decorate your resource methods on the server side, and then the framework basically implements that interface for you. You make a call to that interface, and it makes the remote request. And it's very powerful. You can get a lot of mileage out of very little code with those APIs. I do have a star here because JAX-RS technically doesn't have a type safe client, but MicroProfile REST client, which is I'm hoping will eventually become part of the JAX-RS spec in a future version, does. And so if you wanted to use that, that type-safe REST client, micro-profile REST client is built right in it and integrates very nicely with it. It even has some ways to where you can propagate headers. So for example, if you have an incoming request to your JAX-RS service, and then you want that service to then make another request, like a microservice, you can do that and you can propagate headers like the authorization header. So you don't have to re-authenticate over on that next service. You just propagate that from the initial request. Other popular REST HTTP clients available. Java 11 has a really nice one now that's available in the JDK. So if you're using Java 11 or above, I'd recommend looking into that. That is more competitive with some of these lower level client APIs from Spring or from JAX-RS or MICRONAUT. Likewise, OK HTTP is a very fast and very nice low-level client API. Feign and Retrofit are very similar to the microprofile REST client or the type-safe clients that are available out there, where you create a you create an interface and then invoke that interface. I think I want to ask for questions now. So before I get to questions, let me just go quickly through my observations. And yeah, I'll put on my cap for this. There's a little bit of bias. So with JAX-RS, it is the industry standard. It evolved out of the Oracle Java EE space. It's got great support from lots of vendors. It's flexible. You can extend it easily. There's lots of third-party add-ons you can get for it that even add to its power. And most of those third-party add-ons, you can then apply it to whichever vendor you choose to go with. And it gives you the opportunity to switch vendors. So if you start off with Oracle Helidon and you don't like it and you want to switch over to Red Hat's Wildfly, your application code should just port over there. So there's a lot of things to like about JAX-RS. Some of the biggest disadvantages stem from its biggest advantages. Because it's distributed, because there's multiple vendors, you're going to get into situations where some vendors have some of those nice bells and whistles that you want to take advantage of, but as soon as you do, then it becomes not portable. You can't then switch over to use a different vendor because you're kind of locked in with those using those APIs or those bells and whistles from that vendor. Another thing that I'd like to see changed in this space is that documentation is just very spread out. It's difficult to find here's how you do JAX-RS from soup to nuts all in one place. There's great information over at openliberty.io. There's great information over at Oracle. There's great information at Red Hat's site. So, but there's going to be gaps. There's going to be gaps over here in Open Liberty that might be filled by going over to Red Hat. And it's just, it can kind of get confusing when you want to try to figure out why something isn't working in your application or why, or what you need to do in order to get your application working. So those are, I think, the biggest disadvantages for JAX-RS. For Spring, it's got great support through Pivotal. It is a single vendor, so you have, as they say, one neck to wring. If you're running into issues, you've got one person to talk to. It integrates nicely with Spring Boot. The Spring initializer is very slick, so it's very easy to get up and running and get deployed in a Spring Boot environment. The cons are that a lot of the extensibility that you get with something like JAX-RS, you don't get with Spring. So, like we talked about before, especially things like extending uncommon HTTP methods or to use different HTTP status types. It's just a little bit difficult to do with Spring. And so a lot of this stuff is also a little bit verbose. There's a little bit more code, little bit more boilerplate code that you have to write with Spring that you don't have to write with some of the other vendors or with the other options. With MICRONAUT, it's sleek, it's small. If you're familiar with Quarkus, I would say that it gives Quarkus a run for its money on the supersonic subatomic Java space. It's pretty slick. Now, it also generally takes a little bit less code to get the same functionality as JAX-RS or Spring. The cons here are that there's no built-in content negotiation. That may not be a problem if you're only using JSON. But otherwise, that's a one disadvantage. The other disadvantage is that because it's not as popular, it doesn't have a lot of the third-party APIs. It doesn't integrate with a lot of the popular EE APIs because it's its own stack. So there's a lot of things to like about all three of these. I hope that that you guys got something out of this. I hope that if you haven't heard about these, that you'll go about some of these technologies, that you'll go check them out. Now, if you have any questions, let's start taking those. I think I see some in the chat here. So somebody asks, JAX-RS was once called Jersey. So Jersey is the implementation of JAX-RS. So JAX-RS is a specification. It's a set of APIs, but by itself doesn't do anything. Jersey is one of the implementations. In fact, it's for the longest time, it was the reference implementation. Now that the Eclipse community owns the Jakarta or stewards the Jakarta specifications, there are no such thing as reference implementations anymore. They call them compatible implementations. And Jersey is usually one of the first compatible implementations of the new spec. So for example, we're in the process of working on JAX-RS 3.1. I fully expect Jersey will be the first implementer of JAX-RS 3.1. The next question. Oh, the other part of that question, sorry, is whether Jackson comes with Jersey. I don't know if it does come with it, but it is certainly possible to use Jackson with Jersey. So JAX-RS by default will use JSON-B as its JSON serialization deserialization mechanism, but you can use Jackson. It's very simple to just plug it in and run with it. It's just out of the box. It's going to use JSON-B. Next question: why would you want to use an HTTP verb that is not listed in an RFC? That's up to you. There's times in my experience, I've been able to use the RESTful RFC based verbs pretty successfully. Every once in a while, we get a customer request where somebody says, well, we really want to use this method, and it may not be in there. It might be like a web dev kind of method or something like that that isn't built into the HTTP verbs. So it's definitely something that's going to be up to you and your use cases. I don't necessarily have a great one. Now, okay, I think that's all the questions I have here. If there's any other questions, please feel free to ask now, or to ask me on Twitter. I do want to get back to my book. If you guys are interested in getting a free copy of this, what I'd like you to do is go to, let me pull up the source material slides. And actually, I'm gonna have to go back to this slide here. I want you to go out to Twitter, follow me on Twitter so I can get in touch with you. The first 3 people to answer my question on Twitter, which is, which of these 3 technologies do you generally tend to go to first? Or if you've never used any one of them, to just answer which one you would like to try first. Tweet that to me publicly. I'll get back to you, and I'll have to DM you to get your email address. And the first 3 people to get it will get a free copy of this book, this ebook. So that's all I've got. Good luck to everybody. And I hope you guys have a great conference.